Hello all. I thought in this video I would demonstrate how to create a CICD workflow for a sample application using our all-in-one DevKit. So we will go from an existing project that has no workflow at all and build one that performs tests, does a static code analysis with our Sonar cube, and if everything passes, then it will build a Docker container and push that container to our gitea registry. So let's go ahead and get started. I have here on my screen a sample Flask application. You can see it runs. It's really just a hello world type application. Um, if I were to try localhost 5000, and set up my code report forwarding, you can see it's just a very basic, it should be a very basic hello world application. There we go. So not much to it. It's not very useful, but it's enough to demonstrate what we're doing. Okay, so you can see that I already have this application pushed to my gitea repository called demo CICD. All right. Now within this project, I've defined a couple of things. I've done a quick set of PyTest cases. All it really does is just make sure I get a status code 200 on my main route. And I've also set it up to do coverage. So if I run PyTest, you can see I get a 100%. And if I do coverage run -m PyTest, I get a nice combination of the two. So and then if I were to say just coverage report, you can see I get my coverage results, which is nice. It's at 100%. And so something like coverage XML will write the report to an XML file. So with that, I've also created a Docker file. Doesn't really do much. From Python 3.12, sets a working directory, copies requirements.txt, installs the requirements, copies the rest of the files in, and just runs Flask. It's not really meant to be super functional, just to demonstrate this would be a way to Dockerize the application. It's really not, that wouldn't work in a production deployment, but it's enough for demonstration. Lastly, in this PyProject toml, I wrote a really simple tox configuration. All it's going to do is test my application using coverage, run PyTest, and coverage XML. Yeah, so if I were to run tox, you can see that it's installing all my requirements. There we go. And then it wrote my coverage report here. So with that, I'm going to go ahead and dive into our work. So what we're going to want to do is have a clear idea of what our workflow wants to look like and what we want to get out of it. In order to make a gitea actions workflow, we want to make a directory .gitea and then workflows. Once we've done that, we're going to create a YAML file for our workflow. So touch gitea workflows. I'll just call this demo.yaml. And so here it is. So what we're going to do is we need to first give this workflow a name. So name CICD demo on, this will determine the trigger actions. So I want to do this on two different trigger actions. I want to do it on push. I'm not going to define my branches, and I want to do workflow dispatch. So we're going to go ahead and define the jobs that will be a part of this workflow. Because I'm trying to demonstrate, I'm going to turn off Codium. I don't want it to autocomplete. So I'm going to do this in two different sets of jobs. I'm going to make a test job and a deploy job. Okay. For our first job, for test, I want to line this out. I'll pseudocode it. So essentially, I'm going to check out my code. I'm going to set up Python. We will install test framework. That's Tox. We'll run tests. Then we'll sonar cube scan. And finally, sonar cube quality check. Okay, so that's going to be my test job. Then my deploy job is going to be check out my code. I'm going to log in to my registry. We'll build and push the image. And then we'll do a log out of registry. And because of the way we have our stuff set up, we're bind mounting the Docker socket. I don't want the image to be left on my Docker host. So I'll also do clean up local image, something like that. So that gives me a rough idea of what I want to accomplish in this. So let's go ahead and fill this out now. So on my test job, I need to define which runner it's going to run on, and I only have one runner, so runs on Ubuntu latest. Okay. We'll define our steps, and we'll start. So name, checkout code, and we can do name, set up Python. In this case, I'm going to do 3.12. Name, install Tox. Let's run tests. Sonar scan. Sonar quality check. All right. There we go. Now for each of these named steps, we're going to fill in some information. So for checking out code, we're going to use a pre-boxed action. So uses actions checkout v4. For setting up Python, we'll do uses actions setup Python v5 with Python version 3.12. That will basically make sure that Python 3.12 is set up on this Docker image. Now, the way I wrote the unit test, I could have installed all my dependencies here when I install Tox, or I can have Tox do the installation. I'm just going to keep it compartmentalized and have Tox do the installation. So we're going to do run pip install Tox. Now, remember that I have a PyPy cache mirror, so I want to make sure we use that. So I'm going to set some environment variables. You could pass them here with pip install, index URL. You could do it right there to keep it a little cleaner. What I'm going to do is I'm going to do them as environment variables. So pip index URL equals equals http:// proxpy port, where is it? 5050 50/index, and then we want to do pip trusted host proxpy. There we go. That will make sure to pull talks from our mirror. Now to actually run our tests, it's going to be pretty easy. We're going to just run talks. Pretty basic. If you notice here in my toml here, I don't actually define the environment variables. I could define them here if I wanted to. I could, add it to the commands. Just to be safe, I'll make sure, because Tox is going to download and install, so I'll just make sure and add the same environment variables to this step. It shouldn't need it because I've already set it, but let's go ahead and leave it there. For our sonar scan, we're going to do uses. There's a pre-built action for this, so it's going to be sonar source / sonar cube scan action v4. And finally, we're going to do our quality check. So uses sonar source. We're going to do sonar cube quality gate gate action, and this is going to be v1. Okay. Now we'll come back to the rest of this in a second, because I'm going to have to do some extra work on a few of these here. So for deploy, let's do the same thing. Runs on Ubuntu latest steps, and then check out code. Like that. Log into registry. Build and push image. Log out of registry. And finally clean local image. Okay. So checking out our code, we're going to do the exact same thing. The reason I have to do this 2 times is because it's a different job. It's actually going to run in a separate container. Okay. For logging into our registry, we're going to use docker / login action v3. For building and pushing the image, we're going to do uses docker / build push action, and we're going to use version 6. If you ever wonder which version to use, all you really have to do is just copy the name of the action and just come up and just Google it. Find where the action is hosted on GitHub. Go over to releases and then do tags. So you can pick a specific minor version, but what you usually want to do is pick out the latest one that's just a major version. Anyways, that's the quick way to figure out which one you want. The nice thing is if you end up using renovate along with this, it will tell you when you need to change it. So that's nice. Back over to here, our log out of registry. You could do it a couple ways. You could just do like a run command. In fact, I think that's what I'm gonna do. I'm just gonna say run docker log out, and I'll add to this here in a second. And finally, we're going to do a run, and I'll fill that in here in a second because I'm gonna have to do some stuff first. Okay, this is the basic gist of what we're gonna end up doing. I'm gonna need to create some accesses for some of the stuff. Let's start with Sonar Cube first. So I'm back here in Sonar Cube, and I want to create a new project right here. We're going to call this demo CICD. I'll use the global setting, create the project. We're going to use other CI, and I'm going to create a token here for this particular project. I think we talked last time you can do tokens at the global scope, a project scope, or a user scope. In fact, I think I may have. No. Anyways, we'll just let it create one. I'm going to give it no expiration and generate the token, and we'll copy this. So what we need to do, we need to create a few items for our sonar scans to work. So we're going to set some environment variables. We need to do one for sonar token. We need to do one for sonar host URL. And then you can do one for sonar scanner ops, or you can put a scanner properties file in your directory or for your project. That's what I'm actually going to do real quick. So we would call this sonar. I'm trying to remember what it's actually called. Not sonar project properties. There we go. And in that file, we want to define the properties of our project. So we're going to do sonar.project key equals demo CICD, and also sonar.python.coverage.report paths equals coverage.xml. I'll save it. That way the sonar scanner will just pick all this stuff up so I don't have to specify it. But I do need to specify the sonar host URL. Now it doesn't really change. I could probably statically do that. I could set a actions variable at my user level. I could do it on a project level, wherever it kind of makes sense. And we're also going to use these same environment variables down here for our quality check. Okay. So let's go ahead and create these. So I'm going to go here, and in our project, we're going to go to settings, actions, and first thing I'm going to do is I'm going to create a secret for the sonar token, like that. And we'll use this token. And then under variables, we can do sonar host URL. Like I said, if you don't, since this isn't going to change, you could set it much higher up. I could set it here at the project. I could go under my individual users settings, and I could set it here as a variable for my user. You notice I cannot set secrets at an entire instance scope, but I can set variables. I might as well set it here, and you can see I've actually already done that because this isn't really going to change, and this way I can use it for every single project. While I'm at it, I'm going to also, well, I'll come back. So I actually have sonar host URL and the token set up. So that satisfies these. What I need to do now is reference it. So we're going to do, the token is secrets dot sonar token. Okay. And here we're going to do vars dot sonar host URL. And this is what I want to use for both of them. There we go. So that sets up pretty much everything I need. And things too, like my pip index URL and my pip trusted host, I could certainly set those up as variables. In fact, it's not a bad idea, really. So let's do pip index URL proxpy port 5050 / index. And I could call this pip trusted host proxpy. Okay. Now back over here, we'll replace this with vars.pip index URL, because this isn't going to change either, so might as well vars.pip trusted host. Okay, I'm going to use that for this one too. All right, very nice. So on any branch that we push to, or I can manually kick this off, it's going to run on this runner. It's going to check out my code. It's going to set up Python 3.12. It's going to install Tox through our proxpy mirror. It's going to run our tests, and Tox is going to install what it needs to install through the same mirror. Sonar is going to scan our project, and it's also going to basically check the quality gate of it. Basically, how good is your static code? So now we're down here on our deployment. I'm going to check out my code again. So logging into the registry. What we want to do here is I want to do with registry, and we're going to do username and password. So the registry is not going to change, really. So what I'm going to go ahead and do is I'm going to create a installation-wide variable of, we'll just call this registry host, and we'll do this one as in fact, I'm not supposed to be doing that. Okay. Confirm. And what am I missing now? Let's see. My registry username, I can use any number of users. The way that gitea is organized, my user is kind of like my organization. So the packages get uploaded directly to my user. The registry belongs to my user, I should say. And then I can link specific images back with projects or with repositories. So I'm just going to go ahead and do registry username dqueen. That's fine. And I want to go ahead. Oh, actually, that was not the right spot for that one. I'm going to make that one a per project setting. And that's great. What I need to do is I need to create a set of credentials to use it. So for my user applications, I had already made one previously, but I'm going to delete that one, create a new one. So we'll call this demo CICD registry token. My permissions are just package, read and write. And there's my token. I'm going to copy that, and I'm going to go back. Here we go. This is in my repository. I will add a secret next to my Sonar token, and we'll call this one registry O token. Okay. I think that's all the access stuff I need. So the registry is going to be registry host. We'll do this one as registry username and registry token. Okay. So with that in place now, we can move on to our build and push options. Build and push v6. We're going to do with push true, otherwise it'll just build, it won't push. And then we want to do tags. So our tag is going to be vars.registry host slash vars.registry username slash, and then we call this demo CICD latest. Personally, what I tend to do is have it tag it with the branch name if I'm not running on the master or main branch, and if I'm running on master or main branch, I'll tag it as latest, but I'm not going to fool with that for this example. This is okay, the Docker logout, except I'm going to log out of vars.registry host. And finally, cleaning the local image, because like I said, I'm bind mounting the Docker socket, so actually the build is really occurring on my host instead of like Docker and Docker. So I don't want that image lying around there. I just want it to be in the registry. So we're going to do Docker RMI, and this is the image. Okay. So I believe that's just about everything we need. Now, one thing I want to do is, and this doesn't necessarily make a lot of sense, but it's just for demonstration purposes. I don't want the deploy stage to run if the tests failed, right? Now, obviously, if this fails, this job won't even run. And if this job doesn't run and the quality check doesn't run, and if the quality check doesn't run, what I want to happen is I want the deploy job to not run unless the test job was fully successful. So I need to put an extra piece in here, which is needs test, the name of the job. So it needs this to successfully complete. So the way I've set it up, it's not going to run the deploy if any of these fail. So if the quality gate check fails, it's not even going to run the deploy job. Be that as it may, just for demonstration purposes, I'm going to show something here. I'm going to put a clause so that I don't want to run this if the quality gate action does not pass. So I'm going to say if, condition, that's essentially what we're doing, equals passed. Because the gate check is either going to say passed or failed, right? In order to share outputs in a side of the same job, you can reference them directly with, steps, dot, the name of the step, and so forth. In order to pass it between jobs, I need to actually capture an output and publish it from the job so I can pick it up from another one. It can't dive into test and then, the name of the job and so on and so forth, right? It can't do that. In order to make this quality check a little easier to consume, I want to give it an ID. So the ID I'm going to give it is Sonar Cube Quality Gate Check. Okay. I just did that so it makes it easier to reference. What I need to do is I need to capture the output of this step. So after runs on, I'm going to define my job outputs. I can do lots of different outputs here, but the one I want to do is this already has an output that it's creating. It's in the built-in action. So I just need to capture that and publish it, attach it to the main job. So we're going to call this quality gate status. That's the key of this output. The value is going to be steps dot sonar cube quality gate check, the outputs from it, and then the output is called quality gate status. If you want to see what it was called, I'll show you how you find that real quick. So again, kind of like when you're going and looking for what version to use, I can come into here, I go to action.yaml, and I can see that it has an output that it's creating called quality gate status. And you can see it either comes off as passed, worn, or failed. I only want to advance if it's passed. So this is the output I'm capturing. See, right here. So basically, of my steps, this particular step, which I identify with an ID, the outputs of it, which we found here, and this is the name of the output. So you can kind of see how I got from point A to point B. That will assign that to an output called this. So down here, what I want to do is I want to reference that output from the previous job. So we're going to say if needs, so from the needs right there, which needs, so needs.test dot outputs. Okay, so we're referencing our outputs here, and then this is the output. Okay, that's the output. So if that variable equals passed, and that's all I have to do. So this will only run if this condition evaluates to true. Now, like I said, I didn't really have to do it because if this isn't passed, this would fail. I guess it maybe come off as a warning, but if this isn't passed, then this wouldn't run anyways. But you get the idea. So with all of this set up, this really kind of should be it, unless I fat fingered something, which is entirely possible. So let's find out. Git add, git commit, add, CICD workflow, origin main. So we're going to go over to gitea here, go to actions. So you can see it's already done some stuff here. It's set up the job, checked out my code, set up Python 3.12. It's installed Tox, and what's nice is I can see that it's actually going to my proxpy. It's running my unit tests, and you can see it wrote my coverage report to XML. It's actually running my sonar scan right now. Now, ideally, what will happen is in the not too distant future, I will see the analysis right here. So execution was successful. Now you see something interesting. I have 100% code coverage, but I do have a security hotspot. And even though this job was successful, my deploy did not actually run. Well, it doesn't really matter that I had the hotspot. The quality gate passed. That's all that really matters. You'd have to check your quality profile and see what your profile is set to. It probably says that it's okay. It's treating it as a warning. So it's passed. It means I had something wrong with my registry. Oh, username and password required. I could have sworn I added those. Let's look and see what the problem is. Well, we had registry host, registry username, and registry token. Let's see what the problem is here. So settings, I have my registry username. I do have registry token. It's possible that it actually doesn't like registry host. Let's find out. Username and password are required. Let's see here. Checking my reference over here with registry. Bars.registry host. And I want to say vars.registry username and secrets.registry token. So I just forgot something. Okay. Fix docker login vars. Okay. So we'll wait through this again to complete. It shouldn't take very long. A lot of the stuff is cached. Let's see, that goes pretty quick because all of our Python modules are cached. Okay. Execution was successful. We'll see if our quality check passes. Yep, so the job is complete. We move on to the deploy job. Our login actually succeeded this time, so now we're going to build and push. That's done. We logged out and we cleaned up our local image. We can see we untagged and removed it, and the job was complete. Great. So let's go check packages. It says we don't have any packages yet, but that's because packages don't actually belong to your repositories. They belong to your organization or your user. So interestingly enough, I have to go, let's go here, and so the way you find where your packages are, you can click this and it'll take you right to it, but you can go to your profile and packages, and there's the one that we just pushed. If you click on this package, here is where you can actually link it to a repository. So to do that, I can go to settings, select repository, demo CICD, and update repository link. Now, if I pull my demo CICD, pull up the repository, I can click on packages, and now you can actually see this Docker container there. So when I click on it, it shows you all the information about it and how to pull it, and so on and so forth. So with that, about 39 minutes in, longer than I wanted to go, but this shows you a full CI/CD workflow of taking an application, testing it, doing quality checks on it, and building it and deploying it. So I hope you learned something. And if you liked the video, give it a like, comment, and let me know what you think. And see you next time. Thanks.